Hello, this is Paul from Foresight Tech. In this lecture, we're going to introduce the concept of independent or dependent events, which is the foundation for multiplication rule. That's one of the most important rules. We are going to find the probability for compound or complex events. Okay, so what is independent or dependent? Let's look at this definition. Okay, suppose this time we were going to do experiment in 2 steps. It's not only do 1 step. Okay, so we have the first step and the second step. If we say A is an event happened in the first step, B is another event happened in the second step. Okay, so if someone you remember the compound is A goes first and then B, right? Okay, so we usually say like this: the second step B is, if we define if B is independent on A. What is independent? Independent means no relationship, right? The exact define is this: the outcome of A does not affect the outcome of B. Okay, no effect of A on B, no matter what A happen, if A succeed or failed, no matter what, and the B always has the same outcome or the same probability. Okay, means A will not affect B, right? A not affect B, so this time B is independent on A. Okay, and the second, this opposite, what is say B is dependent on A. Of course, is A will affect B, right? Or the outcome of A does affect the outcome of B. Okay, if A happen in this way and B have one probability, if A happen another way, okay, B have another different probability. Okay, see, the outcome of B was affected by A, right? So keep in mind that these 2 definitions. Now I have a few examples. So the first, we have this result first. Okay, if we do 2 steps, the first step if you put it back or with a replacement, and this time the 2 step, so always be independent. Okay, let me see. With the replacement can cause independent events. Okay, so the question like this: if a car is selected the first time, okay, from a deck of cards, and then see replace with the replacement and then replaced. Okay, keep in mind that. Okay, what does it mean? The first you pick a car and then put it back, and then the second car is selected at random. How about the relationship between these 2? If A is even, the first step we get a red car. B is another event. The second step we get a black car. Okay, do you think the outcome of A will affect the outcome of B? Okay, you think about it. How many outcomes for A? Okay, only 2 outcomes. So the first time let us do this step by step. Okay, outcome of A we have 2. Either A happen or A does not happen, right? If A happens, so it means the first we get a red. Keep in mind that replace, what does it mean? Okay, put the car back. Okay, then we're going to look at the second step to going to find the probability of B. Means what? Is 26 out of 52 classical model. Why is this? Okay, we can say why is 26? Because we have a success for black. How many? 26 black car, right? Left. Still there. Why is 52? Simply say because we have 52 cars in total. Why is there 52 cars? The first you pick the car, but remember you replaced, you put the car back. So the total sample size, okay, the total number in the sample space is 52. Successful for black is 26, so 26 out of 52 is 1/2, right? The second, we're going to, if A does not happen, what will we get? Okay, it means the first you get black but replaced. So we look at the second step. no matter what you get. So we put it back. See, it's the same. So there are total of 52 cars. And how many black? 26. You will get the same answer. Means what? No matter A happen or does not happen, what kind of outcomes never affected the probability for B, right? Never affected the second step. See, we can get this conclusion, okay? Because the outcomes of A do not affect B, right? A does not affect B. So B is independent on A. Keep in mind that the results with the replace is independent. Why? Because you put it back, you never change anything, okay? Look at it. Another results. This is the results. Look at these results. If we change not with the replace but without the replace, this time we will get another opposite results. It's dependent. Okay, the question is like this. The first day you pick a car, however you not replace, okay, without the replace, and then you're going to pick the second car. Okay, look at these two events. The first step you get a red. Still the similar question. The same question. Okay. First step you get a red. The B is the second step you get the black. So do you think now the first will affect the second? Yes, this time it does. Why? Let's look at the detail. Outcome of A we have two, either happen or no happen, right? So we look at the happen first. If A happens, it means the first step we get a red. Keep in mind that we not replace, not put back. Okay, and then look at the second step. Okay, we're going to withdraw. We're going to pick a car randomly, but this time the probability changed. How many? 26 out of 51. The reason how many black car left? The first you get red, so we still have 26 black car there, and how many car in total? No longer 52. Is only 51 because you picked the one car out. Okay, so how many car in total left? Is 51. So therefore, see, we look at it. This is the probability. Okay, for the first outcome, A happens. How about the A does not happen? Okay, so we look at it. Does not happen means the first did not get a red. Means what? It means get a black, right? We only have two colors. Okay, two colors. You get the black and not replace. So this time I look at it. Okay, so don't look at that. This time I look at it. The probability of B is what? How many black car? Classical model. How many probability? How many black car? Because you want to get the black, right? How many black car left? 25. Why is it 25? Because total 26 black car. The first you pick the one, not put back, so it's only 25, right? So how many in total? Of course, it's 51, because from 52 you pick one, not put it back, so 51 car left. So can we compare this probability and that probability? They are different. The denominator are the same, the numerator are different. Therefore, these probability are different, not the same. Means what? Now we have these results. A happen or not happen definitely affect the probability for B. Means what? Outcomes of A does or do affect the B, or the probability of B, right? B is depends on A. This time B is dependent on A. Okay, this means dependent. A affect B, so B dependent on A. If this is dependent later in the future, I will going to show this probability no longer single probability. Why? Because B depends on A. So usually we write this. Okay, this we call the conditional probability, and I will introduce that conditional probability later. If it's a dependent relationship, we will write this conditional probability. This is the second case. Without a replace is dependent. I have two more examples. So can we look at this? If we have a class and contains we have 10 female students and 12 male students in the class. Okay, the first time we pick one student and not put it back. Okay, not put it back means what? Not put it back means without. Remember that we just have without a replacement. You just think about that. Without a replacement. And then another student is selected randomly. Now we have two events. The first you pick a female, the second you pick a male. So how do you think? Without the replacer, we just see should be dependent, right? Why? Because you can go to the detail by yourself, okay? And the first outcome will exactly will affect the probability for B, okay? The probability of B. And this means what? B is dependent on A. In this, so the other same is without the replacer, you will find a dependent, okay? Very important. The last, if a flip a coin the first and then roll a die, flip a coin and then roll a die, 2 steps in the experiment, right? What the relationship between A is the first you get a head up, okay? I mean do this. The first flip a coin, okay? This is the first step. The second step you roll a die, okay? Do you think there's a relationship between these two? The second you're going to get the number 5. Do you think the first step you flip a coin will affect the probability? The second step you're going to get the number 5. Do you think? Yeah, no. The first step never affected the second, right? This is easy to think about it. The first never affected the second probability for the second because there's no relationship, okay? You just imagine. In this time, A that cannot affect the B means B is independent on A. Independent. Okay, here I give you a few examples. Please be sure. Independent and dependent is important. Okay, so for another topic. Thank you.